So please do try this one, guys, and then you can resume to look at the solution. All right, so let R be a real number and f of x is 2x minus r if x is greater than or equal to r, and is equal to r if x is less than r. Then the equation f of x is equal to f of fx holds for all real values of x square. Okay, so first of all, let's eliminate the confusion by taking some value of r. Let's take r is equal to 3 for our consideration. Okay, so for us now, the question becomes f of x is equal to 2x minus 3 if x is greater than or equal to 3. Okay, and it is equal to 3 if x is less than 3. So if you draw the graph for this, guys, okay, so we'll consider the value x is equal to 3. Okay, up to x is equal to 3. Okay, the graph value is equal to 3. F of x is equal to 3. Okay, so that means what? Up till x is equal to 3 and the region less than that, the value of y is simply equal to 3. So if you take 1, 2, and 3, okay, this is what we have. Up till x is equal to 3, considering this region as x is equal to 3, okay, the region below this or the value of less below this will have y is equal to 3, like this probably. Yes. Okay, and the next case is when x is greater than or equal to 3, then f of x or y is equal to 2x minus 3. So basically it will be a straight line like this. Okay, beyond x is equal to 3, it's going to be something like this. All right, so this is your graph. Okay, now as per the question, f of fx should be equal to fx. Okay, so let's check where does it hold true. Okay, we have different cases here. X is greater than or equal to r and x is less than r. So let's verify the given condition in the graph that we have. Okay, let's consider first of all the region below x is equal to 3, or let's consider x is less than 3, because in this region the value of f of x is fixed, which will be equal to 3, right? So for all the values of x less than 3, guys, we will have f of x is equal to 3. So f of fx in this region will be equal to f of 3 only, which in our case here is nothing but f of r. Okay, f of r can be found from this relation, 2 into r minus r. So f of 3 is nothing but 2 into 3 minus 3 from here. When x becomes equal to 3, okay, it will be 2 into 3 minus 3, which is 3 only. Okay, that is equal to f of 3. So when x is less than 3, this relation is holding true. F of fx is equal to fx. So my answer will definitely consist x is less than 3. For general consideration, x is less than r. Now, what if x is equal to r? Same logic. For f of fx, it will be f of f3, which will be f of 3. 2 into 3 minus 3 will be 3 only. So it is again equal to f of 3 only, right? So the relation also holds true for x is equal to 3. But what if we take the value of x more than 3? For example, let's take x is equal to 4, guys. So for x is equal to 4, guys, okay, f of fx will be f of f4. Okay, now f of 4 will be equal to 2 into 4 minus 3. 2 4s are 8 minus 3 is 5. So f of f4 will be equal to f of 5, which is again 2 into 5 minus 10 equal to 7, which is not equal to f of 4, right? And that means this relation will not hold true for x greater than 3. Means the condition that we have holds true only for x less than or equal to 3. Resubstituting or putting back the value of 3 as r, the answer that you want is the third option, x less than or equal to r. It's a very simple question. You just need to observe properly, or you should have some prior knowledge about reflexive functions. Okay, so it's kind of a reflexive function. F of fx is equal to fx is a kind of reflexive function, right? So if you have studied that, probably it makes things very, very easy. Okay, so I hope this is clear, guys. With that, we'll go on to the next question.